In this lesson, I'll show you how to solve motion of a point problems with derivatives. This is question 5 in this series. The question reads, a point moves along a curve such that its horizontal displacement is represented by the equation x is equal to 4t plus 5 in centimeters, and its vertical displacement is y is equal to 3 plus t to the power of 2, also in centimeters. Find the instantaneous velocity at t is equal to 1 second, its horizontal and vertical components, and its magnitude and direction. In order to find the instantaneous velocity, what we need to do is first find the horizontal and vertical components. To find the horizontal and vertical components, we have to take the derivative of both of these equations and substitute t is equal to 1. By doing that for this equation, we find v subscript x, or the horizontal component, and by doing that for this equation, we end up with v subscript y, the vertical component. From that, we can then find the instantaneous velocity using the Pythagorean theorem. So if I take the derivative of x, I end up with x prime, or v subscript x is equal to simply 4. I use the power rule for both of these terms. This becomes 4, that becomes 0. Similarly, y prime, or v subscript y is equal to, this number goes to 0 since it's a constant, and this goes to 2t because of the power rule. So I found my x component equation and my y component equation. Now I substitute t is equal to 1 into both, giving me the following. The horizontal component, vx, is equal to 4, and vy is equal to 2. And I want you to picture it like this. Pretend that we had a graph, and this number, which is in centimeters per second, and this number is also in centimeters per second, represented our horizontal component. Let's call this 4. And this represented our vertical component, 2. We are looking for the actual resultant vector, which would probably lie somewhere right here. This purple vector represents the instantaneous velocity. How do we find its magnitude? Well, with the Pythagorean theorem, pretend that this was a right triangle. We will use a squared plus b squared is equal to c squared. This is our velocity, so v represents c. We'll call this a and call this b. So that is v subscript x squared plus v subscript y squared. Substituting what we know, 4 to the power of 2 plus 2 to the power of 2, square root both sides to get the velocity. 4 to the power of 2 is 16 plus 4 is 20. The square root of 20 represents our velocity. Let's find out what that is. The square root of 20 is approximately 4.8. 4.8 centimeters per second when t is equal to 1. We're also expected to find the direction. That represents the magnitude. The direction we can find using a trigonometric function, namely tangent. Tangent theta is opposite over adjacent. Our opposite is 2, our adjacent is 4. This is the angle we're looking for. Taking the inverse tangent of that ratio, using our calculator, inverse tangent of 1 over 2 gives us 26.5 degrees. And that's it. We found the resultant of v subscript x and v subscript y by vector addition. We also found the direction of the resultant using trig functions. That is how to solve motion of a point problems with derivatives. Make sure to watch the last question in this series where we tackle one more problem related to motion.